Hello everyone, my name is Mitchell Bartoszyk, and I'll be presenting the prototype design pattern. So what is it? So the prototype design pattern is a creational pattern that allows a developer to hide the complexity of creating new instances of a class. This is especially important when a class instantiation is a very expensive process. An example of this would be a class that has multiple classes inside of it, multiple class objects inside of it, and each instantiation requires that you also instantiate those other classes. So the concept is to copy an existing object rather than creating a new instance from scratch. This process is much quicker. Like I said, it avoids the entire process of having to instantiate each of those inner objects. So the main idea, again, of the prototype design pattern is that you start off with a default or prototype object. So in our case, it would be this cat object here. So you could say this cat has a name, Toby, age 3, and a color of orange. So instead of creating a brand new object, you would essentially clone this existing object, giving you two objects with the same variables and all that information, and then you would simply modify that cloned object. So again, this avoids the expensive process of instantiating a brand new object, and then also if this object were to contain other objects within itself, you would avoid that instantiation of those objects. So again, you start with one default object. So you would create that one default object, and anytime you want to make another instance of that, you simply clone it and then modify the clone. So the intent of this prototype is to specify the kinds of objects to create using a prototypical instance. So in the past example would be that cat, and create new objects by copying this prototype. So the motivation behind this pattern is that it is used to avoid subclasses of an object creator in the application, similar to the factory method. So this attempts to avoid the cost of creating a new object in the standard way, which would be using the new class name, excuse me, the new class name method. So a program cannot anticipate the number, type, or attributes of objects that will be created. So again, the prototype method solves this by simply copying one default object and then simply modifying its attributes, rather than having to instantiate a bunch of new objects, because the program can't can't interpret how many objects or the number of types that will be created. So in order to do this, you make the creation of objects at runtime cheaper and more efficient. So the prototype pattern is centered around the implementation of Java's clone method. This is a big part of the prototyping process, or the prototyping design pattern, because the clone method creates a deep copy of an object, which avoids a copy constructor. This avoids extra processing as more efficient, and that it improves performance. So here's a quick class diagram of a simple program that I made. So the client is the cat store, and it contains a hash map of my cats. So this hash map essentially contains two objects that are already created. So it contains a orange cat and a black cat object, and these are accessed, or the key for these objects is accessed with either orange or black. And we also have a getCat method, and then we have our abstract cat class, and then we have the two subclasses orange cat and black cat. So this will make a little bit more sense once I show the demo and kind of explain how the clone method is utilized and so on. So the advantages of using this design pattern are that it provides reduced subclassing. So a factory method often produces a hierarchy of creator classes. The The prototype pattern allows you to clone a prototype instead of asking a factory method to create a new object. The consequences are that a prototype pattern hides concrete objects from the client. So going back to this UML diagram, the concrete objects are hidden in this hash map, which is a private static object within this cat store client. So that essentially hides the two concrete objects that are cloned, so that is hidden from the client. So each subclass of the prototype must implement the clone operation, which make it messy. So again, we have the cat method, which implements and overrides the clone method of Java's default clone method. So again, you'll see that once I get to the demo. So the practicality is today the clone method and prototype pattern are not really recommended. After doing some research, I learned that the Java virtual machine has actually improved greatly since the initial introduction of the clone method. So while it does still save some time and processing power, it is not nearly as much as it used to be. So now the factory method and other creator methods are actually recommended instead. So again, like the performance difference between the new instantiation of an object and the prototype method are now minimal. And also using new also avoids the fallbacks of the prototype pattern. So you get to actually interact with those objects, and you have access to the initial concrete instances rather than just making clones. So now we can go ahead and go to the demo and try to explain this design pattern a little bit more. So here we have the cat class, which is an abstract class. It just starts with simple attributes, string, or the color of the cat, the name, and then an array list of its toys. And then we have the get name, which just simply prints out the name. And here we have the clone method, which is the most important part. So this essentially creates a clone object of a cat and then returns that clone. So it'll create a clone of the original instance. So each subclass of cat will implement its own constructor, add cat method, and set name method. And then we have this clone method, which again overrides Java's default clone method. Here we simply have a function that returns all the toys that a cat has, and we also have the constructor, which just gives it a name of nameless, a color of unknown, and then gives it a toy list containing a mouse and a laser pointer. So the two default toys are given, the mouse and laser pointer, because these are toys that all cats will almost 100% of the time have as their toys. So cloning again avoids creating a new array list object and also pushing these to the array list. But if you had a much more complicated program where you had a class containing different objects within itself, this would be avoiding creating all of those different objects, where this simple program is just sort of avoiding creating a new cat and then creating the array list, which isn't too expensive, but as the program grows and you have more complicated objects, you avoid this very expensive process. So we have the orange cat and the black cat subclasses. So each of these has its own add cat class, which just simply says, orange cat added and black cat added. And then each has their own set name, and then their constructor, which just sets their color to either orange or black. And then we have our cat store class, which would be the client. So it contains a static hash map of a string cat key to value pair. So we start off with cat store having one single instantiation of both orange cat and black cat. So these are the two objects or instantiations that will be cloned every time a new cat is needed. So the client would start off, we would have a cat store object, and then each time a cat wants to be created, cat store would simply call get cat and then provide a string color, so either orange or black, and then this will return a clone of the given cat color. So this will access the mycats hash map, and then let's say we want to add a new orange cat, we'll simply do the cat store.getCat, provide orange, and this will return us with a clone of the original orange cat. So my simple main function here adds an orange cat named Toby. It displays his toys, and nothing has changed. So he simply creates a clone of the orange cat method and changes the name to Toby. So again, it just copies all these attributes. So Toby has a mouse and a laser pointer and no other toys. So it avoids having to create a new cat object using the traditional new expensive way. So we just use a simple prototype since not many things are going to need to be changed about Toby. So next we add a black cat named Max, and then we add a ball to Max's toys. So we add the wool ball, and now Max has a wool ball. But the most important part of this program is that towards the end, down here, we add 100,000 instances, or we create 100,000 instances of orange cat. So the first we use the cloning method, and we utilize the prototype design pattern. So given that the Java virtual machine has improved greatly, and also that my computer has 6 cores and is pretty fast, both of these processes happen, or these loops happen extremely fast. So here we use the prototype design pattern, which only takes 9 milliseconds, and then in the next loop we use the new method or the traditional way of creating an object to create 100,000 instances, and this takes 12 milliseconds. So first the prototype pattern is used, taking 9 milliseconds due to the caching and performance of the clone method. And then next the default instantiation using the new method is used, resulting in a 33% decrease in speed. So that is the end of my presentation. Thank you all for watching and have a good day.